My brother loves Stargate. I just told you the name of the movie. So much for ruining name that tune. Please regret just. Okay, this is a very hard chapter because there's three different and related pictures you have to keep in mind. The picture of the population, the sample, and the sampling distribution sample. You have a glare right there on sample. Can I fix it? Can I shade it? No, this just looks really, really weird. It says sample right there where the glare is. Okay, let's say we wanted to talk about student heights at UW. So if we looked at the population graph, what would it look like? Probably something like this. We've got most of the students are in the 5 to 6 feet range. There's some students who are in the 4 to 5 feet range, and even students who are shorter than that, but it's rare, right? Those tails taper off. On the high end, there's students in the 6 to 7 feet range, although there's fewer, and even taller than 7 feet, but that's rare. And we have this nice, pretty, we're playing with the bell curve at first. Let's talk in a minute about what happens if it's not a bell curve. But this is the picture of the population. Now, if we take a sample, we hope it will look like this, but it's not going to look exactly like that. First off, this is a nice continuous curve. For the sample, we would have to do a distribution, and maybe it would look like this. Notice the similarities here. This general shape matches this general shape. Now, just as an example, we didn't happen to get any students in this range. Okay, bad luck. Sometimes that happens. We have a bunch even higher than 7 feet. We didn't get anybody lower than 4 feet. Okay, just luck of the sample, that can happen. This curve should be similar to this curve. Will it ever be exactly like the population curve? Well, only if you sample infinitely many people. There's always going to be some variation otherwise. And that's called sampling variation. You can't do anything about that. But it's important to know as you take more and more samples, this picture becomes closer and closer to the original population. Okay? This is a totally different beast. Unfortunately, it's called sampling distribution. That's unfortunate because sample and sampling are so similar, students often get them confused. But this is a different question. This isn't what's the probability of a student, but what's the probability for my average. See, if I take this range here, I can find the probability of a student being in this range. Here, I want to find what's the probability my average is in this range. So it's going to look more like this. Notice it still has a nice bell curve shape. That's because we started with a nice bell curve shape. If it was normal before, the average has probabilities that are also normal. What happens if it's not normal? We'll talk about that in a second. Right now, I want you to notice this became skinnier. The standard deviation here is smaller. Why? What's happening here? Well, is it possible to get a student who's super tall? Sure, that happens. Is it possible to get an average that's super tall? The answer is that should be more unlikely because in order to get an average that's super tall, every person in your sample would have to have been a super tall person. So this becomes less likely, this becomes less likely, and here in the middle, this is where it's very likely. You're supposed to get an average very close to the true average, okay? So this is a theoretical, that's why I can draw a curve instead of a histogram. What would happen if I took lots and lots of averages? Well, most of my averages should be here. A couple averages should be here. The chance of an average being clear out here, so minimal that it's almost zero. So close to the line that it looks flat. That idea is hard to get and really important. So we're going to have a couple videos trying to explain this. If you're confused right now, don't feel despair. Okay? The idea is that I want you to get that there is a probability distribution for averages. It's different than these pictures, and the difference is that error is going to be smaller here. Let me explain it with a different way in a new video.